honest, up until this point, you would have only been given this side of the equation, and maybe you would have had to get it to look like that side of the equation. This would have been the question, and this would have been the answer. Or that would have been the question, and this is what you would have needed to get to be the answer. And so the way that we would have gone, I'll put it in green, it's kind of more like review. The way that you would have gone up until this point is from this side to that side. And the way that you would have done it would have been multiplying by, what do I call these? Common denominators. We would have gotten common denominators. So this guy would have been multiplied by what? Good. X plus 2 on the top and the bottom. I'm not going to spend time today because you guys saw the video on Friday, but the long idea short is if you had, or if we had gotten common denominators and gone this direction, we would have found this guy. The dilemma is with this section, we're not going here, that direction. We're going this direction. We're going from the answer to the question. We're going backwards what we're used to doing. And so the way of doing that, we're going to have to learn how to do or how to make or how to form partial fractions. I know it's not going to necessarily seem like a big deal to you right now, but here's the idea. These two are simpler fractions. Their denominators are just one little baby factor each with like a constant on top. These two are simpler fractions. So what we were doing before was taking a complicated thing, and then breaking it apart into simpler pieces. And now, what we're saying is, okay, well, if we have learned how to take the simple and make it complicated, or how to take the simpler and put it together, we also need to know how to take it apart. And that kind of makes sense in life in the sense that, okay, it's good to take simpler pieces and put it together, but sometimes it's also necessary to take it apart or pull it apart. The application of this doesn't really come up until calculus, but the math is definitely a pre-cal or algebra 2 level as far as being able to do it. So we're introducing, once again, some more skills that you guys can develop that could be put to good use later. But once again, we've normally gone from the simpler, putting them together. Now we're taking the together and pulling it apart. And how we do that is what you guys were introduced to on Friday. Now, this is a big old huge chart with lots of words, and you could have written down everything. It's from the book. Snazzy thing is that there is this term, once again, decomposition, which we've kind of seen before. Decomposition, pulling it apart, taking it apart, finding it simpler pieces. But here's the short and sweet of it. So you guys should have these notes already taken, right? First of all, double check really quickly. I fixed this at the beginning of class. Do you guys have a greater than or equal to? Check your notes. Do you have a greater than or equal to? If not, go ahead and put the little or equal to. Divide when improper. When the degree at the top is higher than the degree at the bottom, when you have a numerator over a denominator, if the top wins, you're going to do long division first. But if the top doesn't, then forget that step altogether and say, well, I don't know, go to step 2. Step 2 says factor the denominator all the way. Step 3 says form partial fractions. And there are linear factors and quadratic factors. Linear factors are simple like x plus c or x minus c. Maybe that's the way that you guys are more used to. X minus c. You could have another one, x minus d. You could have multiple linear factors, and we just put little unknowns, a's and b's, representing constants. For quadratic factors, the struggle is sometimes you'll have a quadratic that can't be factored down anymore. And here's an example of one. If you had x squared plus 4, you can't factor that anymore. You kill a puppy if you try. X squared minus 4 we could do. To x plus 2, x minus 2. The x squared plus 4 is what we would call irreducible. It couldn't factor anymore. And so when you have a quadratic that can't factor any further, then he's stuck down there. We have to form our partial fractions a little differently. Since it's a quadratic, we don't just go 1 degree less as a constant, but 1 degree less as a line now. And that was in that big, huge chart that you guys probably saw, should have seen, on Friday. And you might have some combination of the two. You might have a linear one and a quadratic one, or 2 linear ones and a quadratic one. The weird thing is if you do have one of these guys who has like a higher power, we would call it a repeated one, and I'll show you an example in just a second. You might have to go ahead, and if say it was x minus d squared, you'd have to do x minus d and x minus d squared. So if there is a repeated guy, you just see a squared, you might have to do the single and then the squared. We always count up to the highest power. It just kind of depends. Now, I might have shown this a little bit differently on Friday because that was from last year. No, I think I actually stole it from Precalc Honors this year since the timing measured up well, and I think I told you guys that on Thursday, but you should have had at least the main idea. Do you guys get to do this example on Friday?
Yeah.
Okay. So I'm just going to do it really quick. You don't even have to write it. You can just follow along in the notes or just hear me explain it. Because maybe that explanation is kind of hard to hear the video. Sometimes it is, especially when it's like in a whole classroom and not in headphones or something. So, long story short, look at your work. The first question we should have asked ourselves is it improper? What do you guys think? No. Because what degree is higher? The bottom. It's not top heavy, the bottom. The bottom wins as far as the degree, so no dividing. So instead we go to step number 2. Look at step number 2, you should have it right there. Step number 2 says to do what to the denominator? And when I factor, it takes a lot of time, you guys already saw me do it. When I factor, then I form my partial fractions from these factors. And the factors, there's one with x minus 3, and there's one with x plus 2. Okay, so since these factors are linear, what did we on Friday put on top?
A
And
B B.
the whole point is to find the A and the B. Now, if you guys look at the beginning of your notes, isn't this the exact same example? So do you know the A and B based on what was already given to you? Yeah, it's 2 and negative 1, but the question is, how on earth do you find it yourself? 2 and, oh, there's a 2. There's no negative 1. Just a hint, you can't always just steal what's there. So, my hint, not even my hint, the process of solving it the long way would be, we don't like fractions. Come on, we've all said that before, right? We don't like fractions. So question, how do you always get rid of fractions? Multiply. Multiply by? Well, reciprocal sadly would also get us the denominator. So let's just multiply by the denominators. And who has the most denominators? That guy. So I'm going to multiply x minus 3, x plus 2. So far it's matching up okay?
Yes.
Okay. What I do to one side I have to do to the other. But to be less confusing, I'm going to do it to both the terms, because it would have to distribute anyway. So I'm going to do it to all the terms, not just this guy, not just the whole side, but each one individually. So x minus 3, x plus 2, he needs to get multiplied, and x minus 3, he needs to get multiplied. Now guys, what do you see cancel out?
X minus
This whole thing, right?
X minus 3.
Good.
And X plus 2.
So one cancels, but the other remains. You guys see it? So A is going to get multiplied by x plus 2. B is going to get multiplied by x minus 3. What have we done so far? Checked whether or not it was improper. It's not, so we did not divide. Number 2, factor the denominator. Make partials out of that denominator. Number 3, multiply by the big denominator on both sides. And if there are multiple terms, do it to each and every one. Number 4, simplify. And number 5, solve. This is probably where it got confusing. Because how many equations do you see? Each one. But how many unknowns?
3.
3. X's, A's, and B's. It's all about how you look at it. You guys see how this side has 1, x, and 7? On the left-hand side, you have an x term, and you have a constant. On the right side, let me rearrange this just a little bit. And I'm going to pick out all the pieces. I'm going to distribute and then put all the pieces with x's together. So I have ax plus bx, taking this term plus that term. I'm going to have 2a minus 3b. Why am I underlining this with green and this with blue? The x terms must have made the x term, right? And the non-x terms must make the 7. So check it and see if this makes sense. So 1x must come from a plus bx. Pause. Do you see what I did? A plus b combines with the x term. If this was 2x and 3x, it'd be 5x, 2 plus 3x. This is 1x and 6x, that'd be 1 plus 6x, or 7x, right? I factored out my little baby x and said, hey, this guy had to come from these two added together. And so what else can I say? What's my other equation? Take the blue. Got it. Now how many equations do we have? And how many unknowns? Oh, still 3. Wait. What can I do with my x terms? If I divide, do I even need to really stress about the x, or is the whole point a plus b getting 1? The whole point is a plus b getting 1. Now guys, think about it. What chapter are we in? Chapter 7. 7.1, we were doing substitution. 7.2, we were doing elimination. 7.3, we were solving much harder systems with like 3 and 4 equations and 3 and 4 variables. Question, what's the way that you want to use to solve 2 equations, 2 variables? Do you want stair-step row echelon, elimination, or substitution? Sounds good. Can we solve for maybe A? Some of you elimination people, that's probably what I would have done. The substitution definitely works. Because right now, all we're doing is using our skills from 7.1, 7.2, and maybe even eventually 7.3 to solve. So we end up with 2 minus 2b minus 3b. If I subtract the 2, that's 5 equals negative 5b. If you guys look at that beginning example, didn't we get b equals negative 1? And what's that term for taking this and saying, hey, we also need to find a, let's go back substitute. So we'll go plug them in, say, hey, sweet, now that you know b. A is going to equal 1 minus negative 1, a equals 2. Look at those original equations. I think you got x plus 7 over x squared minus x minus 6 equal to, a goes above the a denominator, and b goes above the b denominator.
Wow.
So basically it's us taking the complicated things, seeing maybe what its pieces were, what the simpler pieces were as far as its factors, and then saying, hey, I know what I want it to look like, let's use math to try to figure out the only possible way that could happen. So get rid of the denominators, we all hate fractions. Group the x terms as one equation and the constants as another equation. Get rid of the x's because now that we've grouped it, we don't need them anymore. And then just use the 2 equations, substitution, elimination, eventually maybe row echelon form to solve. And then we're done. Did you guys get to any other examples besides this one?
No.
Okay, this was like the end. Here's the crazy thing. There are harder types of problems where the factoring is harder, or there are more factors, where maybe a quadratic guy will come up, and so that's going to make things a little different, or this repeated guy might come up. There are ways this gets a little trickier. And to be honest, there are only a couple. There's like one shortcut that can kind of help. But there is a really, 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 really cool shortcut for the simplest types of problems like the one you just saw. There are 2 little baby linear factors. All you're missing is an a and a b. There's none of this crazy like more than one fraction with kind of the same denominator. None of this crazy like ax plus b numerator stuff. If you just have a very simple linear factors that are not the same or not shared at all, there is a kind of cool trick, and it's called the thumb trick. I'm going to show you the thumb trick. The sad thing is, I mean, it's cool and not cool. The cool thing is that it's really nice and easy if you learn it. The really sad thing is that it's only for the easiest types of problems. But it'll lead us to a shortcut that'll help us with the harder types of problems. So as you guys get this problem down, write down the thumb trick. Up here on the board, my thumb sadly won't cover everything. It's going to be more like a palm trick, but it'll still kind of work. Bummer, it's warm in here, but the temperature shows it is not very warm. Give everybody in your group a quick high five and say Happy Monday. Some of you are falling asleep.
No, you're not getting out of our
Waking him up, waking him up. Curse. I know. Sure. Whenever I get one,
That's right.
Alright, come on, it's a shortcut. Let's learn this thing, guys. Ready? Shortcut, here we go. Okay. Even with the shortcut, you still have to say, is it improper? Yes or no?
No.
Nah. Why? Who wins? Top or bottom? Okay, so forget step 1. Don't divide. Don't divide. Step 2, what's it say? Factor, right?
Yeah.
Alright, help me out, cool kids. This isn't a hard factoring one. How do I factor that guy? X plus 3. I agree. Which means, my partial fractions would break down 1 for the x plus 3 guy and 1 for the x plus 1 guy. Now, once you have that written, take a second, look at the problem before. If we were to solve this the long way, what would I put up here? A and B. Good. And then what would I multiply everything by? The big old denominator, right? With all the pieces. Then, looking at the example above, when I cancel out all the denominators, what's left, I would say, okay, it's time for my x term equation and my constant equation. The ones with the x's and the ones without. Then I would solve system of equations with elimination or substitution. Ready for the trick?
Yeah.
Okay. This guy named Oliver Heaviside. Actually, look at his picture. He was not heavy. He was like, whoop, but anyway. Oliver Heaviside came up with this idea called the cover method or the thumb trick method. Okay. I'm going to cover with my palm. You guys can cover with the thumb, probably. Cover one factor. Actually, do the same as me, so we can be doing it at the same time. Cover the x plus 3. Literally, cover it.
Yes.
You can see everything else, right?
Yes.
Okay. Peek under real quick. X plus 3. What would his 0 be? Negative 3. Okay, cover him up again.
Oh.
Okay, negative 3 is his 0.
Yeah.
The cover-up method or thumb trick method says, take the 0 of whatever you're covering, and as it's covered, plug into everything else.
Oh.
As the x. What's negative 3 minus 2? What's negative 3 plus 1?
2. What?
Wait, oh.
A is negative 5 over negative 2. Pause one more time. I covered x plus 3 and the 0 was negative 3. I plugged in negative 3 to whatever is remaining. Negative 3 minus 2, negative 3 plus 1.
I'm astonished.
So you guys, go find me B. Use the exact same, but this time you're covering the x plus 1. It has a 0 on. And you plug in. Anybody get negative 3 over 2?
Yes.
Now the book's going to make this look a little funny because there's these weird fractions and the book doesn't like fractions, neither do you. It doesn't like complex fractions. So let me show you what the book answer would be and let's see if we can figure out why. The book's answer is going to be 1/2 times 5 over x plus 3 and then minus 3 over x plus 1. Can you guys figure out what it did? How did the book get there? Yeah, it factored out the 2, but the 2 wasn't like a 2, right? It was a 1/2 instead.
Right.
So if you want, you could write this a different way first. 5 over 2 x plus 3 minus 3 over 2. And we couldn't factor out the x plus 1 or the x plus 3, but we could factor out the 2, but since it's being divided by, that's a 1/2 that comes out. Some of you might be able to see it right here. Pull out the little 1/2, pull out the little 1/2. But that would be the final answer.
Would it be negative 5?
Ooh, careful though. A negative over a negative?
Oh, okay.
Got it. So it was negative 5, but then that would have needed it, and I pulled the 2 away, so I just made it a negative over a negative. Josh.
Negative 5 over negative 2.
Cover up. We covered this guy first. We looked and saw that the 0 of this guy would be negative 3. We covered him up again. And we plug that -3 in here and here, everywhere remaining. You see it? It's -3 minus 2, -5, -3 plus 1, -2. And then how did I get to the next one? What did I cover up, everybody? What was it, 0? Where did I plug it in? -1 minus 2 is -3, -1 plus 3 was 2. Now, if that works, we're going to go back and try the other example that we just did the long way and see if we could have done the thumb trick instead.
Would that work with like the A and B situation too?
An A and B situation, as long as the one time it won't work is if we had one of these repeated guys or something was shared. That's the one time it won't work. But the cool thing is even in these harder ones, the idea behind the trick is going to actually help us simplify that process too. Final answer, the way the book would write it. Let's go back and say, hey, does the thumb trick work on him? Okay, well, on him. You guys don't have to write the whole thing over again if you don't want to. I'm just going to quickly insert a blank page and say, okay, what if we had solved this knowing the thumb trick? Guys, make sure I'm writing it right. It was x plus 7 all over x squared plus minus 6. Okay, it wasn't improper, we didn't divide. We went to go factor it and we ended up with x minus 3 plus 2.
Yes.
Ooh, what order did I write it in, just so that we can be consistent? Oh, same order. Okay. Alright, cover it method. You tell me what to do. What's this here? 3. Plug in.
Over 5 is 2.
Now what?
What's 0? -2. Plug it in. 5 over -5 equals
Thumb trick?
I like it. Yeah.
It's nice. Bummer is it only works on the easy ones, but hey, easier ones just got easier.
Yeah.
The idea behind the thumb trick, right? The idea behind the thumb trick is when you go to multiply the denominators on both sides, constant A ends up not even considering the x minus 3 because that's what was in his denominator. And he ends up being multiplied by x plus 2. Constant B ends up not considering the x plus 2 multiplied by the x minus 3. There is another way to think about the thumb trick and to use the idea of it. But you can't just go straight to the answers like these two simple ones we're able to do. Let's take a harder example and let me show you how to apply the idea of the thumb trick to simplify solving this nasty problem. Now, the very first thing that you should notice as you're writing it down, is that it's improper. So we have to divide. You guys see it? The degree of the top is higher, right? So I'm going to go ahead and off to the side, so that's kind of like apart from the work. You guys can go like as far right as possible. We're going to do this division. And remember, the top drops in the box. Top drops in the box. So I have x to the 4th plus 2x cubed. Now some of you are thinking synthetic division, but we do not have a nice factor to put in. No, we're doing polynomial long division. It's way easier. Doesn't make us factor that denominator at all. Okay. I know it's been a while for some of you guys with polynomial division, but let me just walk through it and hopefully help you review as you go. We look at x cubed into x to the 4th and say, hey, if I have an x, that'll work. Then I have to distribute to each and every term. X times x cubed? Yeah, matches, which is what I want. But I have to go to every other term also. So what's x times 2x squared?
2x cubed.
Oh, well that's ironic. It doesn't usually happen that way, but they match also. And what's x times x?
X squared.
Okay, that's more normal that they don't match. Since this is division, what do we always do after multiplying?
Subtract.
We have to subtract. Now, you guys all know subtraction is dangerous when you have polynomials. Because when I subtract the whole thing, where does the subtraction need to go? So I'm going to go ahead and switch each and every sign to opposite. They all ended up being positive, so then it just happens they're all negative. And now I go down and say, oh, well, that one cancels, that one cancels. Sometimes all of them do, sometimes only one or two. What goes here? Now we ask ourselves the question. Well, hold on, pause. Bring everybody down. With polynomial division, it's nice just to know exactly what you have left so you don't leave anybody out. We have to compare this guy with that guy and say, can x cubed multiply by any whole variable to get there? And the answer is no, it's too small. Well, guys, what do we always call in division the piece that's too small that's left over? Not extremes, but remainder. Good. Now, what do we do? Oh, extra. It's just the wrong one. Left over, remainder. Okay.
My brain is working in different ways.
Ready? I can rewrite this whole blah, 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 blah. Okay? I can rewrite him to be x plus 5x squared plus 20x plus 6 all over x cubed plus 2x squared plus x. The whole piece plus the remainder over the original denominator. That's what we normally do in fractions, like when we're doing division with numbers. We would show like 2 and 2/3 or something like that if we were dividing with numbers. So the remainder goes on top of the original denominator. Now, what did that division do? It let us see the only real fractional part that we need to break down. The way it was written, like an improper fraction, had some whole stuff in it. We don't need to deal with breaking that down. X is just X is just X. Leave him as is. But who do I need to break down? The fraction. So that's the guy that I'm going to do the partial fraction decomposition. That's a snazzy way of saying it. The partial fraction decomposition to. So let's go ahead and start how we normally start. We've divided. Good. Now it's time to factor. I'm just taking this guy, spotlighting him for a second. The x is still important. We'll have to come back to him as we write our final answer. But for right now, we're just breaking this guy down. So, you guys see anything that we can do to factor that denominator? Okay, let me actually do that here to save us a little bit of work. I guess we could have factored when we rewrote it from up there. Factored an x, and we end up with x squared plus 2x plus 1. Can we factor this trinomial? Yeah. What multiplies to b? 1 times 1 is 1. And then we have 2. What multiplies to be 1 and adds to be 2? 1. Good. So we end up with x. You guys see how that's a little different than the other ones that we've done? First of all, there are 3 factors, and second of all, this guy is squared. Yeah, it's matching. So you could write it with a little squared on top, but let me show you what's special about, I kind of had him back here in the linear factor bit. I said, ooh, sometimes you're going to have, okay, let me show you how that works with repeated linear factors. We're going to make a partial fraction with the x, a partial fraction with the x plus 1 by himself, and a partial fraction, not with the other x plus 1, because that would just combine, but with the x plus 1 squared. We got to count up to the highest power. So normally we just put 1, but in this one, we got to put 1 and to the first power and to the second power. The nice thing is since the inside, they're all linears, I can still just say A and B and C. But remember, no thumb trick method, no straight to the answer because of this nasty little squared thing going on. But we can still use an idea from the thumb trick method. Thumb trick method. We would look here, and we would say, hey, this 0, right? Okay. We're going to use the zeros in just 1 second, but first of all, can we all agree that if we do have to do some math, the fraction's kind of disgusting? Can we agree? Okay. If the fraction is kind of disgusting, okay, wait, we're going to go back to the original solving procedure, and we're going to get rid of all those fractions. Do you remember how to do that?
Yes.
Okay, how do we get rid of all the fractions?
Multiply by the denominator.
Yeah, the big old denominator, right?
Yes.
So multiplying by the big old denominator, we multiply by x times x plus 1 squared. The whole point is to get rid of all of that, guys. And I'm going to use that for every single term over here. So I have x times x plus 1 squared, x times x plus 1 squared, x times x plus 1 squared. If you notice, every single guy is going to have something cancel out. He takes away one of the x plus 1s, and this guy takes away both of the x plus 1s. So see if it makes sense what's remaining. For those of you guys, there was too much blue going on. All this denominator is gone. A has both the x plus 1s. B has an x and an x plus 1. And C just has an x. Now if I had tons of time, I would go through and solve this the long way. And I'll explain it to you, but we're not going to solve it that way. The long way, and then show you the shortcut and be like, look, it's so much nicer. Kind of like I did with the thumb trick. Since there's not a lot of time, let me show you the idea. You guys remember in the problem we did the long way, just before the thumb trick, how we had the x terms and the constants? We made two equations, the x term equation, the constant equation. We had a's and b's and we solved. In this one, we have a and b and c. So we have 3 equations for 3 unknowns. I wonder if we have 3 different types
All we do.
of terms. So to do it the long way, we would FOIL everything out. We would take anybody who has an x squared, like bx squared, and eventually like ax squared, we'd put all the x squareds in one equation and get rid of all the x squareds and just have a's and b's and numbers. Then we would get and go collect all the x terms. There's one right here, bx, another one right here, cx. Another one would come out of here, 2ax. We put all the x terms in an equation. And then we go looking for all the non-x terms. And we'd end up with 3 equations with 3 unknowns. We have to solve that big old system of equations with probably the stair-step method. Or, ready? Remember how I said a second ago we're going to use part of the cover-up method or the thumb trick method? Who was the guy that we plugged in, or we would have plugged in if we could have? 0 and -1. The reason we can't do the thumb trick method is we're missing 3 and we only have 2 zeros. But even though we can't do the thumb trick, we can still use the 2 zeros. And let me show you how we're going to use the 2 zeros. I'm still going to look at them and say, hey, I think they might make this easier. I'm still going to plug them in. But check out what happens. I'll leave it red. Check out what happens when I plug it in. Kiddos, you see all kinds of x's, right? We're going to plug 0 in for all of them. So what happens if I plug in 0 to 5x squared? 0. What happens if I plug in 0 to 20x?
0.
0 plus 0 plus 6 is?
6.
Well, that side just got a lot easier. What happens when you plug in 0 here?
0.
Plus 1
1.
squared.
1.
1 times a is 1a. Okay. What happens if you plug in 0 here? Ooh.
0.
B times 0 times 1 is still 0, right?
Yes.
What happens if you plug in 0 here?
0. Oh.
We just got one of our answers. So what can I now do?
Plug that baby in.
Yeah, come up here and say, oh, since a is equal to 6, let's just say from now on, 6 instead of a. Okay. What's my next term to plug in?
-1.
Alright. If I plug in -1, positive 1 times 5, that's fine. If I plug in -1, it's a little harder when it's not 0, but that's okay. Let's see if it still might do something. What happens if I plug in -1 here? 0. What's 0 times anything?
0.
What happens if I plug in -1 here?
0.
0. What happens if I plug in -1 here? But what did we just find? Oh, well, hold on. That's 11. 11 minus 20 is -9. If -9 is negative c, what's c?
Sum equals that.
Go team. So what can I do with c?
Plug that baby in.
And here's the struggle. Do I have any other zeros to do?
No.
But we just learned if you plug in x's, maybe like with the numbers, it kind of simplifies everything. So even though we ran out of zeros, guess what we didn't run out of? Numbers.
Oh.
What's something else we can plug in? What's something easy? 1! Exactly. Could you plug in 2 or 10 or 20? Yes, but would the math have gotten harder?
Yeah.
So I'm going to plug in at x equals 1, because we only have one more guy to solve for, right guys?
Yes.
So 1 times 5 is 5, 1 times 20 is 20, 1, well, 6 is on its own. What happens if I plug in 1, 2? 2 squared is 4 times 6 is
24.
I got this. 1 plus 1 is 2, 2 times 1 is 2, 2 times b is whatever, 2b, not 2b. And then 1 times 9 is 9. That ends up being 31. This one ends up being 33. Pretty quickly, couldn't we get b also?
Yes.
What did we not have to do?
We didn't have to.
We didn't have to foil. We didn't have to make 3 equations and solve a system. Oh no, it's a negative. Thank you. But wait, are we totally done? We just have to write our answer. And our answer would be the x has been chilling waiting for us. And then our a over x, which is 6 over x. Our b over x plus 1. And then our c over x plus 1. So, thumb tricks is a great method. If it doesn't work, it still has a cool shortcut for us to use by plugging in x. Guys, get cards for Tuesday to do tomorrow. But you might get stuck somewhere with those quadratic things. Some of those questions tomorrow will go over. Okay?
I mean,
Bye guys, good job.